Hello students, in this video we are going to see NEET Physics 2020 solutions part 1 discussing 8 questions. Okay, we will see how to solve it very easily one by one. This is first question. The phase difference between displacement and acceleration of a particle in a simple harmonic motion is option 1 3 pi by 2 radian, option 2 pi by 2 radian, option 3 0, option 4 pi radian. Phase difference we are supposed to find between what and what? Displacement and acceleration. The displacement of a particle in a simple harmonic motion, in a simplest way we can write as y is equal to a sin omega t. Acceleration of the particle, a is equal to minus a omega squared sin omega t. You can get this by differentiating this 2 times with respect to time. Okay, but this minus sin omega t, that you can write as sin omega t plus pi. Sin omega t plus pi will come in the third quadrant, therefore there will be minus symbol. So minus sin omega t will be equal to sin omega t plus pi. This a omega squared as they are. Is it clear? How do you get this? I already told you, differentiate this 2 times. Or we can say according to definition, a is minus, definition of simple harmonic motion, a is minus omega squared y. So here a minus omega squared y is a sin omega t. So we can even use this. Also sin omega t plus pi is minus sin omega t. See, if you want to represent them graphically, this and all only explanations I am giving. Okay, no need to discuss all these things here. Just giving this so that you can very well understand the question. So little related ideas are also I am giving. Okay, ideas also I am giving. Okay, so x is equal to a sin omega t. The displacement is sine function. Acceleration minus sin omega t function, minus sine function. Is it clear? This is increasing, this is decreasing. So we can say they are out of phase, or phase difference is pi radian. Compare this to get the phase difference. This is sin omega t, a sin omega t. This is a omega square sin omega t plus pi. Sin omega t plus pi. Therefore phase difference is pi radian. So you get the expressions in terms of sin omega t and see something coming extra here that determines the phase difference. Is it clear? Answer is fourth option, pi radian, fourth option. Second question. 2 bodies of mass 4 kg and 6 kg are tied to the ends of a massless string. The string passes over a pulley which is frictionless. See the figure. Okay, we have seen the acceleration of the system in terms of acceleration due to gravity g is. This is a diagram given. One is 4 kg, other one is 6 kg. 4 options are given. Option 1 g by 2, option 2 g by 5, option 3 g by 10, option 4 g. So this device is called as Atwood machine. Is it clear? We know the formula for acceleration. A is in the case of Atwood machine, A is equal to minus m. A is equal to m1 minus m2 by m1 plus m2 into g. The proof we are not going to consider here, but this is a formula for the acceleration of the blocks or system. Here m1 is 6. Always take m1 to be the greater mass, m2 to be 4. The substitute 6 minus 4 by 6 plus 4 into g. 6 minus 4 is 2, 6 plus 4 is 10. This g will come as it is. 2 by 10 is 1 by 5. 1 by 5 into g. Okay, this would be 1 by 5 into g. Correct option is 2. Go to the third question. Third question in our order, don't forget it. So here the question number is given according to the order in which we are doing it. Okay, so a long solenoid of 50 centimeter length having 100 turns carries a current of 2.5 ampere. The magnetic field, the center of the solenoid is, again this is mu naught 4 pi 10 power minus 7 Tesla meter per ampere. 4 options are given. Option 1 3.14 10 to the power of minus 4 Tesla. Option 2 6.28 10 to the power of minus 5 Tesla. Option 3 3.14 10 to the power of minus 5 Tesla. Option 4 6.28 into 10 to the power of minus 4 Tesla. Okay, you can use the formula directly. Direct application of the formula. Magnetic field center of the solenoid is given by the formula mu naught capital N I by L. This capital N by L, that only small n, number density or number of turns per unit length. Substitute the values. Mu naught 4 pi 10 to the power of minus 7, N is 100 here given, then I 2.5 here it is given, divide by L, here it is given as 50 centimeter, convert into meter 0.5. 0.5 can be written as half. So 4 pi 10 to the power of minus 7 into 100 into 2.5, divide by half, so multiply by 2 here. So 2 into 2.5, 5 into 100, 500, 500 into 4 pi, 2000 pi, 10 to the power of minus 7 as it is. This is 2 pi into 10 power 3, 10 power minus 7, so 10 power minus 4, so 2 pi. 2 pi we know 6.28, taking pi as 3.14. This 10 power minus 4 as it is. So what is the answer? 6.28 10 to the power of minus 4 Tesla. Fourth option is correct. Okay, go to the next one. The ratio, the answer is given as 1. The ratio, that is first option, is correct. The ratio, you can just straight away say, or you can see the explanation which we are going to consider. The ratio of contributions made by the electric field and magnetic field components to the intensity of an electromagnetic wave is C is equal to speed of electromagnetic wave. Okay, this one you can take as, you can consider as a knowledge type question, and the answer is 1. That's why I just already I have marked it here as 1. What is the explanation then? If we do not know it as a general idea of the electromagnetic wave, how do you explain it? See, electromagnetic wave is this. It has got oscillating electric field and magnetic field. So these two together make the electromagnetic wave. Whenever we say electromagnetic wave, we will have to think about the electric field as well as the magnetic field. This is for the wave propagating in the positive z direction. Now intensity, basically it means energy crossing per unit perpendicular area per second. That is why the SI unit of intensity watt per meter squared. Energy per unit perpendicular area, so meter square in the denominator, but per second, energy per second is watt, so watt per meter squared, the unit of intensity. But electromagnetic wave is given, so it should be, you have to consider electric field and the magnetic field. Okay, now from this energy crossing per unit area, perpendicular and per second, we get this average energy density. See, from this we get the intensity of the electromagnetic wave equals the average energy density of the wave multiplied by the speed of light. This proof again not necessary here. Okay, we are briefly looking at the solution side. So from this we get the intensity of the electromagnetic wave equals the average energy density of the wave multiplied by the speed. Average energy density of the wave means average energy density of the electric field plus average energy density of the magnetic field, because the wave, electromagnetic wave, consists both electric field and magnetic field. So we will have to consider average energy density of the electric field plus average energy density of the magnetic field. So average energy density of the wave into speed of light. This is what just now I said, average energy density of the wave, meaning average energy density of the electric field plus average energy density of the magnetic field. See this notation. This is the average energy density. So this is a symbol for average value. Average value of the energy density of the electric field, average value of the energy density of the magnetic field multiplied by C. You will get intensity. This proof we are not giving here. Next step. We know UE is half epsilon naught ERMS square. That is average energy density due to electric field of epsilon naught ERMS squared. You will have to be very careful. This is ERMS square. Okay, but this is average energy density. If you simply write energy density as half epsilon naught E square, that may represent instantaneous energy density. So when you take average, you will get this. The proof again we are not going to consider here. So average energy density of the electric field is this. Here this is ERMS square. Half epsilon naught. ERMS square you can write as C square BRMS squared. Why? Because C is ERMS by BRMS. Or that C is instantaneous values ratio also okay. C is E by B, or E naught by B naught, or ERMS by BRMS, because the electric field and the magnetic field vary in phase. But here we are using C is equal to ERMS by BRMS. Okay, and then average value of the energy density half epsilon naught, but C square is 1 by mu naught epsilon naught. Why? Because why? C is 1 by root mu naught epsilon naught. That comes in electromagnetic wave chapter. So half epsilon naught 1 by mu naught epsilon naught BRMS square. This epsilon naught you can cancel. B squared by 2 mu naught. So average value of energy density, this BRMS squared by 2 mu naught, BRMS squared by 2 mu naught is average energy density of the magnetic field. So we are proving average energy density of the electric field is same as average density of the magnetic field, magnitude wise. Therefore whatever is contributed by this is also contributed by this, because they are equal. So to the electromagnetic wave, electric field and magnetic field, the contributions to the intensity of the electromagnetic wave, the electric field and magnetic field contributions are equal, so you can say 1:1. Is it clear? So option is 1. We already gave this. You can remember it. You don't have to be doing every time. Electromagnetic wave, you can remember it and say the contribution by the electric field and magnetic field are equal to the intensity. Okay. Next question. In a certain region of space with volume 0.2 meter cube, the electric potential is found to be 5 volt throughout. The magnitude of the electric field in this region is option 1 0.5 Newton per coulomb, option 2 1 Newton per coulomb, option 3 5 Newton per coulomb, option 4 0. Okay. So 4 options are given. Now you should think about a relation between electric potential and electric field. We already know that E is minus dV by dr, but it is given potential is found to be 5 volt throughout. That means constant. So potential is constant. So differentiation of a constant is 0. So electric field is 0. Okay, but differentiation of a constant is 0. Therefore electric field is 0. So fourth one is the correct option. Suppose if you forgot this formula, if we forgot this relation, so what we can do, think about an example wherein you will have equipotential volume, that is uniform shell of charge. Uniform shell of charge contains equipotential volume. Why? Because inside potential is constant. Uniform shell of charge, potential here is constant. Let's say it is 5 volt. Since, and also we know that electric field intensity inside a shell of charge is 0. If you do not know this formula, you can just think about this example wherein you should be knowing potential is constant, electric field is 0. So your correct option will be 4. Next question. This is average thermal energy for a monatomic gas is Kb Boltzmann constant T absolute temperature. 4 options. Option 1 3 by 2 kBT, K sub B T, K subscript B T. Option 2 5 by 2 K sub B T. Option 3 7 by 2 K sub B T. Option 4 half K sub B T, K subscript B T. This is a direct expression based question. So direct question. So option 1 is correct. 3 by 2 kB into T, monatomic gas for each molecule. This is the energy, thermal energy, right? Question 7. Find the torque about the origin when a force of 3 J cap Newton acts on a particle whose position vector is 2K cap meter. Position vector. 4 options. Option 1 6J Newton meter. Option 2 minus 6 I Newton meter. Option 3 6K Newton meter. Option 4 6 I Newton meter. Whenever I say I, that means I cap, K cap, I cap, J cap. Okay. This cap indicate they are all unit vectors. Okay. If you want to have an idea, this will be the diagram. So particle is here whose position vector is 2K. This is y axis, z axis, K, x axis, and you apply a force 3 Newton parallel to the y axis here. So 3 J Newton, right? So there is a torque acting on this because force is there. This is the perpendicular distance, right? So how do you proceed? You know the formula for the torque tau as R cross F. R is position vector of this particle because its x coordinate, y coordinate 0 because it is on the z axis. So 0, 0, 2. So r is 2k cap cross F is 3j Newton. Multiply 2 into 3, 6. K cross j is minus I because j cross k only plus I, but here order is changed. So k cross j, you have, when order is changed, you have to put a minus symbol. So minus 6 I cap. 6, how did it come? 2 into 3. How minus came? Cross product of k and j. Cross product of k cap and j cap. So what is the answer for this? Option 2 will be the answer. Okay, it is not marked here, but option 2 is the answer. Minus 6I Newton meter. That is the SI unit of torque. Then the mean free path for a gas with molecular diameter d, number density n, can be expressed as option 1, 1 by square root of 2 n pi d squared. Option 2, 1 by square root of 2 n squared pi d squared. Option 3, 1 by square root of 2 n square pi square d square. Option 4, 1 by square root of 2 n pi d. This is derived in the NCERT textbook, so directly you can mark the answer as 1. Okay, derivation is given in NCERT book. Is it clear? Thank you. We will meet in the next video. Thank you.